All right, I here try to record a quick video to explain the homework problems, mainly for the homework 2, also related to the homework 3, which you haven't been assigned yet, you haven't started yet. But here I look at the problem 4 of homework 2. The problem 4 says the rear window of an automobile is defogged by a attached thin transparent heating element to the inner surface of the glass. And then by electrical heating this element, a uniform heat flux may be established at the inner surface. And then for a certain thickness, 4 mm thick window glass, and determine the electrical power that is required for a unit window area to maintain a surface temperature, inner surface temperature at 15 C. So here I draw a physical diagram first. This would be the glass, and then the surface area will be unit surface area, okay? The unit glass area, as the problem says, unit window area. And then the inner temperature is given at 25 C. And then the convection coefficient in the inner surface, H in equals to 10. This is T in equals to 25. And on the other hand, the external temperature T out or T infinite out is minus 10 C. And then the convection coefficient on the outside, H out equals to 65. All right. So in addition to this physical diagram that I have been drawn so far, this defog actually will be achieved by a thin, transparent heating element that is attached on the inner surface. So you can imagine this inner surface, which I use the red color to draw, but now I just change it to black color. So this will be the heating unit. And then some students may or may not use thermal circuit because I realize the homework does not specifically, all the homework problems from textbook does not specifically ask you to construct the thermal circuit. But if you are familiar with thermal circuit, this will be very easy to use the thermal circuit to analyze the problem and construct the correct equation for your solution. And then before I do here, I want to refer back. But before that, I want to refer back to the homework 2, the same homework 2, the problem 2 here, which also has a heating unit. And then in this problem, the heating unit is actually sandwiched in between the two blocks. I don't know how many of you think this problem is slightly easier than the problem 4 here. Because for me, I think this problem 2 is easier because it is symmetrical. The heat will be generated at the center. This is the only heat source that is coming from the system. And then this heat will dissipate it from the left side and from the right side. It's exactly symmetrical. So, and then if you use the thermal circuit, and I think you still need the thermal circuit because for the left pass, you will have conduction and then the convection. And then for the right side, you also have the conduction and then the convection, although the left and the right are exactly same. So the thermal circuit will be looking like center, right? The center or the heating unit. So that will be the T center. And then you will go to the left side. The left side will be have the T left infinite. And then the right side, it is also T infinite because the both sides have the same temperature of the air. And the convection coefficient on both sides are the same too. So the H and the H are also the same. And then here you would have for the left pass, you would have a conduction and then the convection. And for the right pass, you will also have the conduction and then the convection. Conduction and convection. And then you can, oh, okay, I see. So the problem didn't ask you to calculate something, but I asked you to plot. So you will still have to calculate these resistance though. So the RCV or conduction, and then you can plot the temperature at the center, and then the so if this is the x coordinate, this is 0 based on what the problem says, right? So here it is 0. And then the center temperature will be higher, and then the left surface temperature and the right surface temperature will be lower than the center temperature. So what I'm going to do is I'm going to just type it out and make it higher. So the center temperature is here, and then it should go to the left one and then the right one. Coordinates, calculate the value of the temperature. Okay, so it doesn't ask you to calculate any temperature in the air, so we don't need to calculate that. So that will be how it looks like. And then for this one, the only heat source is coming from the center, and then the heat is dissipated from both sides of the center. However, here, and you also can say the Q is coming from here. You don't even, some of you may put an arrow here, Q, or some of you may not, because it's intuitively easy to think the Q is coming from the TC. And we don't calculate the Q here in this problem. But however, in this problem 4, it is not symmetrical. But actually, it is the same as the problem 2, because the heat will come from the electrical circuit to a certain point in the thermal circuit. We don't know what it is. We don't know if it's symmetrical or not, but it doesn't matter. Even if it's not symmetrical, we can just put the heat into the circuit. So let's say if I draw this thermal circuit still following left to right, following the physics left to right. And this thermal circuit is slightly more difficult because the heat is not coming from the end of this thermal circuit, because in the past, we typically have the heat transfer from one end to the other. So let's say if we don't have the heat unit, we only have a piece of glass, the red color glass, everything is red without the black element. Then the heat will transfer from the far left, which is the inner air, all the way to the far right, which is the outer air, and then the infinite temperature. In order for the heat to go through this, the heat has to go to the glass, right? This will be the glass inner glass temperature, and it goes across the glass by conduction, and then this will be the outer glass temperature, and then by convection again to dissipate to the outer air. So this will be the convection inner, and this will be the convection outer, and then this will be the conduction. And then if we want to say the resistance, then we put a capital R on each of them. And then this is the case when we don't have any heating unit or don't have any heat, or the heat unit, it doesn't have any power, because the problem asks us determine the electrical power that is needed to maintain a certain temperature of 15 C. So we have to maintain this. If we don't have any electrical power, then you can just use this circuit to calculate the surface temperature, because the inner temperature is 25 and then the outer temperature is -10. You can use this circuit to calculate what the temperature is of the glass on both sides. The inner temperature of the glass, right? Let's say without heating. Then that will be the temperature if you turn off the default heating unit. And you will see this is not satisfying the requirement of 15C. So in order to get to 15C, what we do is we actually put on a heating unit, and then what the heating unit does is actually it inject a Q of the heating unit into the circuit. And now, if we have a circuit like this, does this change our equation? It does, because if you don't have this heating unit, then the left section, the first section, and then the second section, I use a different color. The black section and the blue section are in series, okay? So when Q heating is 0, then the black and the blue in series. I know some students may still say, even with the Q, with the heating unit Q, are the black and the blue in series? So that's why I make this video. So just remind everyone, if we say one resistor and another resistor in series, that means all the Q that's passing through the black should all go through the blue. In other words, all the heat that's going through blue should also going through the black. So in other words, the flux or the heat has to be exactly same between the black and the blue. And now if we have this purple heating unit heat, are this still the case? So, and we know they are not. So they are not in series. So you cannot treat the black circuit and the blue circuit as in series circuit. And there's no R total for them anymore. Instead, you cannot say R total equals to R black plus R blue. You cannot do this anymore, okay? So instead, your equation should be the Q in the black, I say Q1, Q2 in the blue should be Q1 plus Q heating equals to Q2. This is your governing equation. And then the decompose that, the Q heating is the question asked you to. And then Q1, you can calculate it because it is delta T over R1, right? And then Q2, it is delta T of R2. But however, the R2 is the summation of two blue resistance, 2 and 3. And then in addition here, I just want to point out, although I say delta T in the numerator, but the delta T for the first section, it is the first section delta T. The delta T on the second section is the delta T on the second section. And for those of you who still don't know, then the delta T of the black section should be the temperature difference between these two locations. And then for the delta T of the blue section should be the delta T between these two locations. So the delta T would be T inner temperature minus the glass inner surface temperature. And this is the temperature that the problem asks us to maintain at 15 C. And here, for the blue section, the delta T, the driving force will be the glass inner surface temperature minus the outer air temperature. The glass inner surface temperature is again the temperature that we need to maintain. So as you can see, you have one equation and one unknown, because all these temperatures are known. All these temperatures are known. And then the only unknown that you don't have is this guy, okay? And then I use this one to show you the thermal circuit with the injection of the heat, which is also same as this problem. And then for homework 3, you will have a little bit more complex problem, although it's not dealing with the electrical circuit anymore, electrical heater anymore. It actually uses the house situation to introduce another heating energy by the sun. So you're gonna see the homework 3, the first problem. I draw a diagram on the left side to show you the house, the wall situation. The wall may have multiple layers. I hope everyone can do that now. If the heat goes through the wall, it has to go through these 3 layers. But nevertheless, the problem will tell you, in addition to these heat transfer, convection, conduction, whatever, it will have a additional sunlight that shines on the surface of the wall and then provides additional heat to the surface of the wall. So the sunlight energy is fixed for the Earth. You can even Google to see how much sunlight we get on the Earth. And then for this type of question, it is also the same. You have the inner temperature of the house, and you also have the outer temperature outside the house of the air. And then your circuit looks like whatever it is. I don't know how many resistors you would have. That depends on the situation, convection, radiation, conduction, or layers. And then you have to determine at which point the sun injects the Q. The Q of the sunlight, it will inject to the top surface or the outer surface of the wall. So you will determine where it goes. And then if it goes to a point, then you need to construct the energy equation same way that we did here. Because once you inject this point, the left side and the right side is not in series anymore. So you cannot add them together. You only can consider the left portion and the right portion separately, and then you add this injected heat into it. And then these 3 problems I use here to show you the problem can show to you different phases. It can be heating unit on the car, it can be sunlight on the house, or it can be even some other heating mechanism to the problem. But ultimately, what it means in terms of the engineering solution, or how we decompose the engineering problem into the mathematical equation, they are the same, okay?